So I got this idea off Pinterest, and it had a lot of really cool things on there. So I copied it, so thank you Pinterest, and I'm sorry I can't remember which person it was, but it was awesome. So this is a visual representation of the distributive property. In the distributive property, you're taking the number or the item on the outside and you're distributing it to the rest of the items. And the parentheses are important. They tell us that you're going to multiply. So to get a visual idea of this, if we have Angry Bird and you're going to multiply him by the yellow bird, you end up with this first grouping. So you have Angry Bird times the yellow bird. Then you drop down your operation because you want to keep that consistent. So you have your addition sign. And then you have Angry Bird times the blue guy. And you have your second grouping of Angry Bird times the blue guy. So if you go through this and you expand it out, you can see that the red Angry Bird was distributed to each of the items on the inside. So in math, if you have numbers that you can do this with, there are many ways that you can go back and forth between expanding it and then bringing it back together. And if you can do that quickly and efficiently and you're comfortable with it, it opens up a lot of doors to do many other things. It can be reversed too. So if you start with the bottom set, you can see what's common between both groups. So if you look at this set and you look at this set, the common thing between them is the Angry Bird. So you can take the common item and you pull it out by itself, and then what you're left with is the yellow guy and the blue guy. So math is like a language. So if you think of it in English, you can rearrange the ways that you say a sentence and it can still mean the same thing. For example, if you say, I love cute and fluffy kittens, or you could say, or you could be like Yoda and say, cute and fluffy kittens I love, or you could say, kittens, cute and fluffy, I love. So there's a lot of ways that you can rearrange things in English and you still get the same meaning. And if you can do the same thing in math, you will be golden, because math is just another language. And if you learn how it works and you can rearrange the numbers, then it's like solving a puzzle and it becomes really fun. So thanks for watching. For the rest of this video, I'm going to show you some different examples of the distributive property. It can get really confusing at first just because there are so many ways that you can use it. But once you start to see the pattern and you understand the rules that go with it, it becomes a really useful tool to work with the numbers. So let's try this example. We have 7 times the sum of 10 plus 4. And the rule of the parentheses when you have a group is that you multiply the outside number times everything on the inside. So our first group is 7 times 10 plus our second group, which is 7 times 4. So we can expand it to look like this. Then you can continue working inside the parentheses and multiply 7 times 10, and you can multiply 7 times 4, and you get 2 whole numbers that we can find the sum of, which is 98. Working the other way, we can have the 2 groupings at first, and then we can look at the factors inside and see if there's anything in common that we can pull out of that group. So the 7 shows up in both groups, which means we can pull that out as a common factor and leave it on the outside. And what we're left with on the inside is the sum of 2 other numbers that are left over, which is the 10 and the 4. From this point, we can continue working through the inside of the parentheses, which is addition. So we have 7 times 10 plus 4, which is 14. And we could finalize this problem by doing 7 times 14, and we get 98. Here's the last example using colors. So if you know how colors mix, this might be a good visual to see how the process works. So if you can imagine red plus blue will give you a secondary color, and red and yellow will give you a secondary color. So 8 times 3 is 24, plus 8 times 5 will be 40, and you can see those secondary colors underneath. And if you added those two together, then you would have your final answer of 64. Another way to really see this work is you can still have that 8 on the outside and do the work of the addition on the inside, and then you see even more simply that 8 times 8 is 64.